Hello. So I have been lurking on Discord and I've seen this thing, and I thought, well, I did figure this out, but I didn't see reasons why I would not make this into a video. So the question is about whether this is differentiable or not. Well, it's easy to show that this is an actual function. Let's label it f of x. Because through the ratio test, it's fairly easy to show that it does converge. This is how the function defined through series will look like approximately. I think this is 50 elements of the sum. Alright, so now working with this, how do we show that it's differentiable or on the contrary indifferentiable? Well, first of all, it'd be useful to define the notion of a function that sums up a finite amount of elements here. So from k equals 0 up to this n, and we have here just cosine x k factorial over k factorial. Alright. Now, for every epsilon greater than 0, this capital N, such that for every n greater than or equal to capital N, g n of a minus fn of a is less than epsilon, and let's also denote for every a. Alright, so this just comes from the definition of infinite sum, which is just a limit. So this is basically just tackling that. This is the expression under the limit. Alright, so now using that, suppose that the derivative of f of x exists. So now using that, what I'm going to do is I'm going to show that there exists a sufficient n such that the derivative of gn of x is going to be close enough to the derivative of f of x. So what's going to be the derivative of gn of x? Well, let's differentiate it. It's a finite sum, so we can just differentiate the individual elements here. It's no trouble. So what we're going to get is minus sum through sine of x k factorial. Alright. Now we're to look into f prime of a, it's going to be the limit as x approaches a of f of x minus f of a over x minus a. Gonna be a similar thing for g n prime of a equal to, it's gonna be equal to basically the same thing but with different functions. So what I'm gonna do now is I'm gonna show that essentially the derivative of gn of a is gonna approach the derivative of fa. So let's go through this definition. It states that, well, we have already picked a, and we have already picked epsilon. So there exists delta greater than 0, such that for every x such that x minus a is less than delta, this thing is supposed to approach the derivative of f of a, yeah? Alright, it's gonna be less than epsilon. So Now, if we were to look into this entire thing, I'm gonna compare f prime of a and gn of a. I'm gonna show that gn of a is also approaching f prime of a. So let's find the difference between let's find the difference between f of x minus f of a over x minus a with gn of x minus gn of a over x minus a, yeah? And it's going to be equal to the absolute value of 1 over x minus a. Let's just bring it out. And inside this absolute value, we're going to have f of x minus gn of x minus f of a. Actually, let's just write down as plus gn of a minus f of a. Alright. Now we can do, what we can do is, we can take the limit as n approaches infinity here. And what we're gonna get is, essentially, for every a, for every epsilon greater than 0, exists some capital N. And this here implies that for every epsilon greater than 0, we can essentially do is, let's rewrite this expression here. To be more exact, we're gonna say that's less than or equal to the sum of the difference of f of x minus gn of x plus the absolute value of okay, now I can just rewrite it in the other order because it's absolute value. F of a minus gn of a. And regardless of the stuff we pick, including x and a, what we can do is we can pick sufficiently great n. So first of all, let's evaluate 1 over x minus a. Let's call it gamma. And suppose this entire thing is less than some epsilon with index gamma. Alright, so what we have left is this thing. Less than epsilon gamma. Actually, let's define it as the absolute value of x minus a here. And we have epsilon gamma times gamma. Alright, now what we have here is, what we can do is, we can pick epsilon. That is gonna be less than epsilon. Let's call it epsilon theta. It's gonna be less than epsilon gamma times gamma over 2. And let's pick some n such that for every n greater than or equal to capital N, this thing is going to be less than epsilon theta. This would imply that this is going to be less than epsilon gamma times gamma. So indeed there exists an n such that this is going to be less than epsilon gamma gamma. So if we were to take some epsilon, then we can pick another epsilon and call it, well, now that epsilon is equal to epsilon gamma times gamma, so epsilon gamma is equal to epsilon over gamma. So for every epsilon we can just divide it by gamma and get epsilon gamma, and then we can pick stuff that is going to be less than epsilon gamma, therefore it's going to be less than epsilon. Alright, we have figured this stuff out. So there exists an n such that this is going to be less than some epsilon. In other words, this limit over here approaches 0. So what does this imply? This essentially implies that this thing over here approaches 0. Therefore, the limit over here, limit as x approaches a, is gonna be basically the derivative in question. We also make n approach infinity, so it's gonna be f prime of a. Alright, now if we were to look into this, then that means there's an n such that is going to be sufficiently close, so we can do some limit swapping. It's annoying to do, but overall, we were to look into this entire thing, then as we take this limit, then for every epsilon greater than 0 for the upper limit, there exists epsilon 2 greater than 0 for the second limit, as we have already shown here. I'm not gonna write it down entirely, but you can see the trace of thought over here, which is why I can sort of justify limit swapping here. So for every epsilon greater than 0 exists epsilon 2 greater than 0, such that exists n capital, such that for every n greater than, okay, I need to fix my size, okay, 3 pixels, greater than or equal to n capital, the this thing and is gonna be less than epsilon when you take the difference with the f prime of a. So now what we can do is we can just apply this limit over here and get limit as n approaches infinity of this thing, and we're to subtract it from f prime of a is gonna be less than some given epsilon. Now this, not this, wait, I'm stupid, I meant as x approaches e over here. So what we have here is g n prime of a minus f prime of a is going to be less than epsilon for sufficiently a large n. So exists capital such that for every n greater than n capital. Now we're to look at the derivative of g n prime, not the derivative g n prime, just gn. Then if we were to look into this series, I can show that it definitely does not converge. So if we were to write down the Maclaurin series for sine over here, so minus 1 to the power of I over 2I plus 1 factorial times, here we have xk factorial, so xk factorial to the power of 2I plus 1. So what we have here is this factorial that grows really fast. Essentially, we're to look into this thing over here, and then it will be sort of bouncing. So suppose for some n1 it equals to some a, right? Well, if we were to go ahead and pick some n2, and let's pick that n2 just n1 plus 1, it's gonna be a plus this Maclaurin series 0 up to infinity, and then here we're gonna have minus 1 to the power of I over 2I plus 1 factorial times x times n1 plus 1 factorial to the power of 2I plus 1. Alright, now if we were to take a brief look at this, then we have this part over here, and we have this part over here, and eventually 2I plus 1 factorial in the denominator is gonna overpower this thing. However, this thing is gonna be dominant for a while. So if we're to look at this, then every element's absolute value is diminishing, because otherwise the series over here wouldn't converge. We wouldn't be able to take this side of k factorial. So if we were to look into this, the first element is always going to be the most significant one, because the 2I plus 1 factorials are the lowest. So what we have here is a plus, here we will have I equals 0, so that can be just 1. So we have x to the power of 1 times n1 plus 1 factorial over 1 factorial, so nothing, plus some remainder, let's call it q, of x. Alright, so what we can see is we're essentially adding to this thing x n1 plus 1 factorial plus some other thing. Now what we could do is we could show that, well, we need q of x to be some positive number, otherwise it'd be annoying to deal with, so let's expand it out to the second power here. So the q of x is going to be positive. It's going to be minus x to the third power times n1 plus 1 factorial to the third power over what we have here is 3 factorial, so that's going to be 6. Alright, and this is always going to be a positive. Now if we're to look at this abhorrence, then you can see n1 plus 1 factorial and this thing, Well, we can always pick n1 sufficiently large, such that n1 plus 1 factorial cubed is going to be greater than x. In fact, we can pick it such that it's going to be greater than x cubed over 6. And even, in fact, we can pick it such that if we were to multiply it, there exists in 1, such that this is going to be greater than 1. Alright, now how is this relevant? Well, actually, let me bring this into some nicer to work with form. I can bring this out. Alright, and here we have 1 minus x squared times n1 plus 1 factorial squared over 6 plus the remainder q of x, which is going to be less by the absolute value, significantly so. So if we're to look into this thing, essentially, we have here is n1 plus 1 factorial that can rise indefinitely. So this is going to approach negative infinity. This is going to approach positive infinity. Now I'm not going to bother writing down. Actually, this can also approach negative infinity if x is negative, but it's always going to keep the same sign. Alright, now I'm not going to bother writing it out entirely. Too much rigor. And it's fairly easy to show, it's just a lot of writing. But you can see that it definitely diverges. In fact, we can pick a simpler case. We can pick sine. Well, it diverges unless x is equal to 0, then it's really easy to show that it actually converges to 0. Fairly easy case basis is when we pick x is equal to 1, then it's just sum of sine of n factorial. It's really easy to show that it diverges. You can do it yourself. So not a lot of rigor today. That's because I don't bother writing even more. I already spent a lot of time just noting stuff down. So thanks for watching. Bye. It's not differentiable.